Hey guys, Fred here at Math and Engineering. We're back. We're doing some more example problems for trigonometric functions, and I've included the just the rules for the definition, or sorry, for the derivatives above in the pink box. And let's just go ahead and get into these three questions. They're a little trickier than the ones we did before, so let's get started. So for question one, we have f of x is equal to x times e to the x times cosecant x. All right. So if you'll notice here, I mean, it is product rule, right? But we have three terms, and this is just exactly the kind of trick that they're going to put for you in your midterm. Okay, your professor's going to try and trick you, and they're like, oh, you've done a ton of product rule questions with two terms, and you're going to see a third one in there, and you know what? Don't panic. It's not a big deal. It's exactly the same thing. Okay, and we're just going to take the derivative of each term and multiply it by the rest of the function. Okay, so we're going to take the derivative of x and multiply it by this. We're going to take the derivative of e to the x and multiply it by x cosecant x, and then we're going to take the derivative of cosecant x multiplied by x e to the x. So just exactly the same thing. Let's go ahead and get started with that. All right, so we have f prime of x is equal to, and let's just start with the first term. Okay, so the derivative of x is 1 times the rest of the function. Okay, so whenever you have three functions in the question within the function, or three terms with x in them, okay, this is what we're going to do. Derivative of x, which is 1, times e to the x cosecant x. So that's just going to be e to the x cosecant x. Okay, and we're going to add them all together, right? So the next term is e to the x, and e to the x is derivative of that is just e to the x. So, and that's going to be multiplied by the rest of the function. So x e to the x cosecant x. And finally, we're going to take the derivative of cosecant x. And if we come up here, the derivative of cosecant x is negative cosecant x cotangent x times x e to the x. All right. So that wasn't too bad, was it? We kind of just took the derivative of each term and we multiplied it by the rest. Okay, and that's all you have to do. You add them all together and you're good. So if we go ahead and we simplify this, all right, we should be able to factor out e to the x cosecant x, right? Because we have e to the x cosecant x in each term here in the f prime of x. So let's go ahead and do that. Let's factor out e to the x cosecant x, okay? And, well, this is just going to be 1 for the first term, and x for the second term after we factor this out. And then the third term, we have a negative sign here. Let's not forget that, because, that can cause us some problems. And we have a cotangent x and an x here, okay? So we're going to write that down, x cotangent x, and there we go. So that's the solution for question one. All right, now at this point in the video, I do highly suggest that you pause before each of these questions, because they are a little bit trickier and they're going to test your knowledge a little bit, and that would be actually really good practice for a midterms type scenario. So pause the video before question 2 and 3 if you'd like, and try and solve these. All right, try and solve them. Try and play around with the identities a little bit, get familiar, and then continue with the solution and see if you got it right. So let's start with question 2. So we have f of z is equal to cotangent z over e to the z, okay? So another common trick, your professor might, throw in different variables. They might throw in t, they might throw in z, they might throw in r, f of r. Don't get thrown off by that. You can always change the r to an x or the z to an x and then change it back at the end if that's more familiar for you. We'll just leave it as f of z for now, okay? So we'll go f prime of z, all right, is equal to, and as we can see, we have a fraction here, so we're going to apply the quotient rule. So let's go ahead and apply it. We've done that a few times before in previous videos. So we have the derivative of the top, okay, so the derivative of the top, as we come over here, we can see that the derivative of cotangent x is equal to negative cosecant squared x, okay, so negative cosecant squared, and that is going to be times e to the z, okay? And then we're going to go ahead and subtract the derivative of the bottom. So the derivative of e to the z, as we know by now, is e to the z times cotangent z. Perfect. And that is all going to be divided by e to the 2z, right? Because we have e to the z squared, that becomes e to the 2z. All right, perfect. Now, well, what can we do here to make this maybe a little more simple? Well, what we can see here is that in each term in the fraction, the first term, the second term, and then the denominator term, is we have an e to the z. All right, so we can go ahead and we can cancel those, and we can cancel 1 off of here, and that will give us cosecant squared z minus cotangent z over e to the z. And if we want, we can factor out the negative. Let's just go ahead and do it. All right, and negative, we have cosecant squared z plus cotangent z over e to the z. All right, so there's our solution for the second one, okay? Now, like I said, pause the video if you want to try and solve it on your own. This one is much trickier, okay? And this is actually a derivative, and you just need to play around a little bit with the fractions, and I'll show you how to do it, but this is a tricky one, and this also could come on your midterm, these kind of proofs. So as well, understanding how to prove this really helps you remember it. So let's go ahead and prove this. So prove that d by dx of cosecant x is equal to negative cosecant x cotangent x. Okay, so let's go ahead and start that. So we know that the derivative of cosecant x, okay, is equal to, and as I explained up here, cosecant x is equivalent to 1 over sine x. Okay, so let's go ahead and, so these are equivalent statements here, okay? So the left is equal to the right, and now what we can go ahead and, what do we have here? Okay, well we have a fraction, and we can go ahead and apply the quotient rule. So let's go ahead and do that. So we'll say that's equal to derivative of the top, which is 0, times the bottom, so that's just going to be 0. All right, minus derivative of the bottom, so derivative of sine x is equal to cos x. Okay, and derivative, or times the top. All right, and that is going to be over the square of the bottom of the function, so sine squared x. Okay, so, well, how do we proceed from here? Let's just go ahead and simplify this a little more. So we have negative cosine x over sine squared x. Okay, so this point is kind of where the trick is, and if you haven't done a lot of proofs and that kind of thing, this might be hard to get at this point, but this just comes from practice. Okay, so practice the proofs and that kind of stuff, and you'll see how they manipulate the fractions in order to kind of get the result that they want within your textbook usually. So okay, so we have negative cos x over sine x. So just looking at that, I mean, we can rewrite that. We could use an identity here, which we haven't really gotten into. We'll get into that soon. But we could rewrite this as, okay, we have 1 over sine x times negative cos x over sine x, okay? And if you'll multiply those together, you'll see that that's exactly the same thing. Negative cos x times 1 is negative cos x, and then sine x times sine x is sine squared x, all right? And if you remember, and I'll just come over here, if we remember that tan x is equal to sine x over cos x, okay, cotangent x is equal to cosine x over sine x, all right? So that's a little identity that you're gonna have to remember for this proof, all right? And if we go ahead and, so now if we rewrite that, we have cotangent x here, okay? And that's gonna be a negative, and if we recall from before, we have 1 over sine x, all right? And 1 over sine x is equal to cosecant x. So there's the proof. We can just rewrite that as, so this is negative cotangent x, and this is cosecant x. All right, so we've done what the question has asked. We actually wrote it in the opposite order, but as we know, it's exactly equivalent. That's about it, guys. Yeah, we're done with those 3 questions. I hope those were a little trickier, and that you learned a couple tricks from those. Next section, we are going to solve some chain rule questions, and then we'll start getting into trigonometric identities, which will also help with this kind of stuff. Thanks for watching. Stay tuned for those.